In this first video, we will review the homework. Most of you had problems with the first question. The first problem was asking you to determine the stiffness Kt of a single spring such that the force F will stretch it by the same amount as it does for two springs in series. So I was asking you to express Kt in terms of the stiffness K1 and K2 of two springs. This is a very useful exercise because if you have a problem where there are two springs mounted in series, like here, you want to simplify the problem by basically reducing these two springs to just one. So you need to know how to do it. As in any static problem, you should always start by drawing the free body diagram. So this is your body, Kt, your spring, and subject to a force F. Now, in order to be in equilibrium, this hook has to express the same force on the other side. And the system is now in equilibrium. Now we know that the force in a spring is equal to its constant times the displacement, S. So the displacement S is equal to the force divided Kt. Now, let's look at the second arrangement where we have instead two springs, K1 and K2. In this case, if I draw the free body diagram, I have the first system, K2, subject to a force F. Now, in order to be in equilibrium, K2, another force F has to be applied to the other end. Where is this force F coming from? It's coming from K1. So K1, I'll draw it in orange, is also subject to F. And this is because of the third law of Newton, action and reaction. So then on the left side of K1, the hook is also subject to F. So the force here is exactly the same as in the first case, is F everywhere. Some of you wrote that this F, each of the two springs is taking a component of this F. Instead, each of these two springs is taking all of F, because the system has to be in equilibrium. What is added is the displacement. So the displacement S here is equal to the displacement of the first spring plus the displacement of the second spring. Now, if I express these displacements as a function of the force and the constant, I have Fk1 plus, sorry guys, I'll draw it up here. So S is equal to S1 plus S2, which is equal to Fk1 plus Fk2. So, and this is equal to the total displacement, which was this guy here. So it is equal to F divided Kt. In conclusion, I have my F divided Kt equal F K1 plus F K2. And this is due to the sum of the displacements. So if I simplify each f, I get the equation that all of you wrote, 1 over kt is equal to 1 over k1 plus 1 over k2.